Here we have an example. A cylinder 1 meter tall with inside diameter 0.12 meters is used to hold acetylene gas, molecular mass 26.04 gram per mole, for welding. It is initially filled with gas until the gauge pressure is 1.3 times 10 to the power of 6 pascals and the temperature is 22 degrees Celsius. The temperature of the gas remains constant as it is partially emptied out of the tank, until the gauge pressure is 2 times 10 to the power of 5 pascals. Calculate the mass of acetylene that has been used. First we calculate the volume of the container, which is a cylinder. We divide the diameter from the given by 2 to obtain the radius. The cylinder remains constant after the acetylene gas has been used. Note that the volume of the cylinder is given as pi times square of the radius times height. Substituting the values from the given and calculated, we have the volume of the cylinder around 3.6 times pi times 10 to the power of -3 meter cube. It is shown in equation A. Note that the gas has been released at constant temperature and constant volume. The processes involved here are isothermal or at constant temperature and isochoric at constant volume as the gas is used. Since the temperature is constant, then, the temperature before the gas is released, or T1, is equal to the temperature after the gas has been released, T2. This is equal to 22 degrees Celsius. We convert this to Kelvin scale by adding 273 Kelvin and we have 295 Kelvin. Similarly, the volume before and after the gas is released, the volume V1 and V2 are equal. The mass used, noted as mu after it has been partially emptied, is equal to the initial mass M1 minus the mass remaining, or M2. We write this as equation B. We rewrite the ideal gas equation to solve for mass M and take into consideration the relation of molar mass and we have equation C. We consider the condition for mass M1 and mass M2 and substitute this equation B, which we then substitute the values obtained earlier, and we have the value of mu. Here we see that the mass used or released into the atmosphere is about 132 grams.